Good morning, good afternoon, and good evening to our global audience, and welcome to the Veryon Power Hour. Today's session is all about predicting and preventing downtime, and we will be showcasing our latest launch for business aviation. Veryon's defect analysis tool allows you to monitor all defects and corrective actions in a single pane of glass, and we are excited to share it with you today. We're also very excited about today's special guest who will be joining us later. With that, let's jump in and introduce ourselves. Let's introduce everyone and discuss a little bit about the agenda that we'll be going through today. I'm Kyle Sale, Senior Account Executive with Veryon, and I've spent the last decade working in development roles across business and commercial aviation with a focus on bringing advanced tools and technologies to the marketplace. It is a pleasure to be here with you all today. Chris?
Hi there, everyone. Good morning, good evening, good afternoon. I'm Chris Blachut. I am the Group Product Manager here at Veryon, where I lead our diagnostics product, which defect analysis is part of that suite. I've only been here for a few months, but I do have a pretty extensive background in aviation. I started life as a pilot many years ago. Now my focus is helping operators turn maintenance data into actionable insights. So I'm basically here to give teams the visibility to prevent downtime before it happens. And I'm from Colorado.
So it's already a little cold out there in Colorado, I guess. I see in the chat we've got some folks from Florida, and Brazil. So fabulous. How's the weather? Austin, Texas? All right. Well, thank you so much, Chris. We are very happy to have you with us as we discuss AI in aviation, and we learn more about our defect analysis tool. And our special guest today is Wyatt Robertson. Wyatt has led multiple aviation operations. He's been an integral player in the startup of 3 Part 135 programs, and he's a dedicated and passionate leader when it comes to quality and reliability. He's going to be joining us right after the live demonstration of the product, so sit back, relax, and stay tuned as we talk about fleet reliability and defect analysis. Now, Chris, will you go ahead and start us off, sir? And give folks a little bit of a background on Veryon's reach and who we are.
Yeah, I'd love to. So I just want to mention that Veryon is a very comprehensive connected maintenance platform in aviation today. We're not a new company by any means. We've got decades of experience, and we have our foot in everything from maintenance tracking, reliability, troubleshooting, publications. It's all in one system. Our reach is pretty broad as well. We have operators, OEMs, MROs. They all have data of some sort, and this data doesn't necessarily have to live in silos. So when a defect is logged in one of our systems, it becomes part of a living, learning data set, basically. The highlight of this is that we have faster insights, less duplication, united fleet picture, basically. So I do want to call out that we have been in the space for a while here. We do have a lot of data, and we'll talk a little bit more about how that data gets used within the Veryon platform a little bit later on. Kyle, I believe you have a little bit of a question for everybody.
Yes, we are going to be jumping right in with that. Thank you so much, Chris. I greatly appreciate it. I do kind of want to just make a note as we jump into that question that, Veryon does continue to grow. And, a lot of times folks ask us, when we say, who is Veryon? They say, oh, ATP or Flight Docs. But really, ATP, Flight Docs, Case Bank, RCMBT, RUSADA, and now EBIS are all under the Veryon umbrella, which means that if you're looking for an aviation software solution, chances are we not only have one for you, but can likely help with your overall stack. So very excited about that. Now, today, we want to jump right in as we discuss predicting and preventing downtime. So that poll's already hit your screen. We've launched that first poll to really ask our audience, what is the biggest maintenance challenge your maintenance team faces today? Now, we appreciate your engagement, so please jump in, answer those polls. We'll deliver the results shortly. Now, speaking of polls, this year our benchmark report had over 800 aviation professionals just like you respond in and talk about what are some of the top challenges they are seeing. Workforce shortages, supply chain issues, rising OPEX, software challenges, and more were pointed out. Now, please scan that QR code in the bottom left of the screen so you can download your free version of that entire report. Now, something we wanted to highlight out of the report for this session was that buzzword we've all been hearing lately around adopting AI. I love that we're seeing we've got the polls, guys. Troubleshooting efficiently, accessing and analyzing maintenance data, coordinating between flight ops and maintenance, and even some had all of the above. Thank you guys so much for jumping into these polls. Now, something we noticed on this, right, when we hear that buzzword AI, is that 70% of industry leaders see AI as crucial for boosting operational efficiency, but only 30% are leveraging it today. Now, we know a lot of folks are testing the waters on advanced technologies, but if you look at some companies, including Veryon, they've not only been experimenting with it, but have been implementing AI for years. Chris, we're incredibly excited to have you with us today as one of our product leaders. And will you kind of walk us through Veryon's AI journey and some of the exciting developments we're seeing today with Veryon Air?
Yeah, I'd love to, Kyle. Thank you so much. So, AI seems to be a buzzword. A lot of people have heard of like ChatGPT within the last couple of years, but I kind of wanted to demonstrate uh, how Varyon has or how AI has evolved at Varyon and why we're so far ahead of the curve. We didn't just start talking about AI last year. It's been part of our DNA for over a decade, really. We began experimenting with text clustering, early natural language processing way back in 2010. The goal at the time was really, really simple. It was to help techs find patterns that were hidden in maintenance text. Um, and these were things that were like chronic defects, related symptoms, things like that. By 2015, we've moved to the cloud, which basically let us lay a foundation for scalable analytics and automated tagging, basically just replatforming so that we do have capabilities that come along with some of the new tools that also live up in the cloud. Once the foundation was very solid, we recently launched AIR, which is our generative AI framework. This includes intelligent search, automated data clustering, in context recommendations. AIR was specifically built for aviation workflows. It's not necessarily just a generic chat box that's been bolted onto the data that we have. Uh, Next up, when we're looking at the timeline, we have agentic AI. And agentic AI is really, really simple. It goes beyond what you think of like ChatGPT, where you can have a conversation. It's basically a system that can analyze and act. And so it'll understand context, flag anomalies, suggest corrective actions on certain histories. And at the end of the day, what we're building towards is predictive maintenance, and it's at scale. AI agents work across reliability, troubleshooting, planning to eliminate preventable downtime, basically. So this is kind of just to demonstrate that AIR, our new platform, isn't just a sudden innovation within Varyon. It's the next chapter of a long and deliberate evolution. Now I'd like to kind of look at what this means in action, how AIR turns those years of research and development into operational results. So when we're looking at this slide here, what we're kind of looking at is uh, what Varyon Air really brings to the table. And it's turning AI into something that actually helps tax and reliability teams day to day. We're not talking about theoretical AI. This is really practical in aviation specific intelligence. So AIR learns from real maintenance data. It suggests most like fixes first. The goal is basically to have a natural conversation with the data at the end of the day. So you might go in there and ask like, what usually fixes this ATA on this aircraft? Or what is the root cause of the problems on my particular fleet? And then we can jump straight to what the right step is next. And so at the end of the day, what that really means is basically fewer dead ends, hopefully fewer parts swaps, and just faster return to services. When we look at intelligent fleet management, we're kind of looking at the behind the scenes of how AIR is helping managers see what matters most. So what's trending, what's chronic, what can be automated basically. It reduces routine busy work, the manual reviews, the spreadsheets, someone in the corner basically just looking at everything and trying to capture data as it comes in so that it becomes actionable. And so the focus is really to drive downtime a little bit quicker. And so it helps plan maintenance windows smarter and optimize parts usage better. When we're looking at enhanced reliability, this is where AI really helps shift from reactive to predictive. So AIR is there to help service patterns. So it's looking at components failing earlier, component failing to find it earlier than expected, or when ATA trends start to creep up to be able to find those a little bit quicker. So basically, we're looking at things before they go into an MEL or into an AOG to give you time to act. So the point is that all three of these things help faster fixes, smarter planning, early warnings, and they all feed each other really at the end of the day. And so along with that, the more that we use air, we feed more data, the smarter things can get. And so we're basically learning from your own fleet's behavior. And that's why we call it an airworthiness and reliability AI partner, because it's built for aviation. It's not necessarily adapted for it. So in the next slide here, I really like to focus on uh, what intelligence looks like when it all comes together, basically. Like, what are the different components of air? Because air isn't necessarily just a single feature or single platform. It's a full data intelligence platform that's built for aviation here. And so it's the engine under the hood that connects your data with our algorithms and your real human expertise at the end of the day. So if we start at the top left here, we talked a little bit about agentic AI. And agentic AI is basically the proactive side of air. And so these agents are built to understand aviation workflows. They're there to understand things like recurring pattern defects or overdue tasks. They don't just wait for commands. They act when something looks off, like flagging a trend or triggering a workflow automatically, for instance. It's your intelligent co-pilot, constantly scanning for opportunities to reduce downtime. So agentic is very, very, very powerful as far as being a proactive part of your operation. If you look at the conversational AI part of it, that's kind of what you think of your current ChatGPT kind of functionality. It's a natural language interface. So we can literally ask questions in plain English, like show me all the repeat defects on tail 912, or how do I take the cowling off my engine? Well, whatever it might be that might be necessarily. And so it's built for maintainers and managers, not data scientists, because it is purely conversational AI. And so that accessibility is really what makes AIR powerful. Anyone can get insights instantly. So now let's shift over to look at the data. So I mentioned before, we have tons of operators, tons of fleets, tons of data is what it comes down to. And so the bottom layer is the data foundation that we have, which is what truly makes Veryon stand apart. AIR is trained on the largest de-identified aviation maintenance data set in the industry by far. Over 80 million maintenance events, 1.3 million parts, and 2 million chronic defects. That's decades of operational intelligence shaping every recommendation that we make by AIR. And that's where our AI doesn't necessarily guess. It can help recognize patterns with the accuracy of experience. Then if we look at the proven algorithms that we have that help power AIR, so the algorithms are really the core of the analytical engine. These are the machine learning models, refined and validated with real-world data. They're not borrowed from generic AI frameworks. They've been purpose-built by us with the extensive aviation maintenance background that a lot of us have. And so it's used for use cases like defect clustering, chronic detection, reliability trending, those types of things. But at the end of the day, aviation is a highly regulated environment. And so no matter what the guidance is or the recommendations that we have, we still want a human to drive a lot of the decisions that we have. And so that's what helps keep everything very trustworthy. Every air model is trained and reviewed by a network of A&Ps, reliability engineers, OEM experts. But at the end of the day, the human at the wheel is what ensures the AI aligns with how aviation actually works. It's not how a computer thinks it should, basically. So even when systems learns, the guardrails are still in place. And so together with these five components, that's what makes AI, air basically unique. And so now let's shift and talk about why all this matters.
Yeah,
Kyle?
Chris, yeah, I love how you articulated that. And I hope for our audience, I mean, that was very well said, sir, on exactly how the future is coming to fruition now, right? It's just very exciting. It's pretty incredible that right now, kind of that Gen AI is allowing, you to just chat and talk with your fleet. And very soon, the agentic AI is going to allow your fleet to start to talk to you, all with the human at the wheel, enhancing operations, streamlining workflows, and let's face it, making operators' lives easier in the process. Now, and all in an effort to reduce AOG risk. So, all of us here today are part of the mission. We all play a role, from tech ops to safety to ground crews. We are all working hard every single day to increase fleet reliability and keep the operation going. Downed aircraft, missed trips, recurring issues that add up to thousands of minutes of delays all get in the way of being mission ready. And we are excited about sharing a tool with you that is designed to help this. And that is our Veryon Defect Analysis tool. So guys, and we're going to jump right into the demo. We're not going to wait much longer. We want to get going. We want to get to our special guests. We want to get to audience questions so that you guys can ask Chris and myself, all your questions. But this tool, we just kind of want to set it up that it allows you to monitor defects, set alerts, review recurring issues, analyze corrective actions, identify fix effectiveness, share cases across teams for base-wide collaboration, review historicals, determine efficiencies across ATAs as well as at the tail level, and monitor all of these and more data points via Intuit. Chris, can we see dashboards? So let's jump right in. Can we see the Varion Diagnostics platform?
100%. Thank you, Kyle.
Absolutely. Wonderful. Okay, guys. So really quick, we want to jump into this. And now what we've done, and for those of you that need a little bit more information, want your own personal demo, please raise your hand, drop it in the chat. Our marketing team is monitoring that. We will reach out to you personally. But let's give you a quick overview of this tool in action. So right here, you would log into your tool. Now I've got, quite a few tabs at the top. Chronics, I can see recurring. Defects, I can see my one-offs. Alerts, I can set to see, get alerted for defects I want to pay attention to. My dashboards, symptoms, admin, and more, right? Now, quickly, we are on the defects tab. And so what I want you to start to think about this, right, is it basically creates an entirely separate database of every single defect and every single corrective action that's been taken to work to fix it. So just imagine if you're a director of maintenance or a fleet manager and you're sitting there over your morning coffee and you're able to review every single defect that's going on in your system. Now, a lot of folks might be saying, well, how do I get the data in there? Is it difficult? What does it matter what M&E system I'm using? Well, guys, I've got great news for you. It doesn't. We are, basically the system is agnostic of all M&E systems. We can ingest data from any M&E system, whether it's ours or you're using another one on the market. So all of that data gets ingested via the PyReps and MyReps, right? So there's pilot reports and maintenance reports. And basically we're monitoring and making this separate database of all the defects that are occurring. And you can quickly see, okay, what defects are occurring, what corrective actions are being taken. You can even kind of scroll over and see, okay, did these fixes work? Was it a first time fix? Was there no fix attempted? Did we MEL it and kick the can down the road? Did we try something? Let me see what that corrective action was that my team tried. Did it cause any delays? Et cetera, et cetera. And that all continues to roll back through. You can see which type of report it was, the tail ID, when it was reported, when it was resolved, what ATA chapter it was tied to, and the defect ID as well as the occurrence. So now, let's say you're in the system, and you say, okay, I'm monitoring my defects. I've got, my armrest caps are damaged. I'm kind of upset about that. Or maybe for all my Part 135 operators, how often do you get dinged on the Wi-Fi, right? Whether it's, the principal trying to join a meeting or the principal's son trying to watch Paw Patrol, right? We need to make sure that Wi-Fi is working in the cabin. So if that's something I keep getting dinged on, maybe I'd come in here and say, well, let's make an alert. So I can quickly monitor. And we have customers that are making hundreds of alerts, right? Obviously, if there's smoke in the cabin, we want to know about it. We're not going to wait for that to recur multiple times. We want to know immediately so we can, of course, set alerts for that. But I'm going to go ahead and make us a quick rule for a Wi-Fi in-op. So I can drill across my entire fleet, or I can even drill down. If you're a very large fleet operator and you've got, 3604s and 10 G550s, well, you could dial down all the way to that fleet. Or let's say you're even a flight school operating a bunch of 172s, but you've also got some Pipers, you can break it out by fleet. So I'm going to go with my entire fleet, all tails, all ATA chapters, and I'm going to name this a Wi-Fi in-op. And we want to know every time that there is an issue, I'm going to make a description and classify a rule that every time something says Wi-Fi and in-op, I want to know about it. And so we can preview this. If in that date range a defect had already occurred in the last 21 days, you'd be able to see it there, but you can save that. And now you've got that alert saved right inside your system. So no more waiting, no more wondering, no more looking at Excel sheets. You would just be able to pop into your defect analysis tool and see those alerts, via on the go. Now, so now you've got some alerts set. So very quickly, let's start to think, okay, well, I can monitor my defects. I can see what corrective actions we're taking. Well, the ones that I really care about are, I want to see these recurring defects because they are the ones that keep adding delay time, missed flights, cancellations. Those are the ones that are giving me the most trouble. Well, we've got a tab for that. We classify those as chronic defects. So if a defect occurs more than a few times, and this is a subset that you get to pick, we'll talk about that. It's going to do what we call a cluster. It's going to generate a cluster. And across this cluster line, you can see each defect. There's 3 of 6 in this cluster. And we can click into that, and we will in just a moment, but I want to continue kind of showing you. So this orange cluster would say, all right, we've got, inside this, cluster, we can see that it's just kind of gotten in here, right? It's a brand new cluster. A recurring defects, we auto tagged it to say that I want to know if there's 3 defects in 10 days. Or maybe on my business aviation side, I'm not flying, I don't have such a high profile as a commercial operator. I want to know just over landings. So if I've got 3 defects over 10 cycles, I want to know about it. Or 6 and 30, 2 and 10. All those auto tags can be generated by you. But if you say, okay, I want to know every time there's 3 defects over 10 cycles, if a defect occurs more than 3 times, it will then populate one of these clusters. And now that orange dotted line means it's brand new. I need to come in here and validate it. So now again, it's always that human at the wheel. You're validating your data. An example of validation might be, no, maybe we're always doing an O2 check. So if that is recurring, that's not really a defect. I can just go ahead and click right here and junk it, and it'll pull that defect cluster out of my system. But now let's say, and this one looks to be like an issue, right-hand engine has an oil leak. Well, this is absolutely something that's a validated cluster. So I can click in here and I can verify that cluster, and then it will update to green, right? So now we verified that, and that is an issue. And if one more oil leak pops up in that auto tag of 3 defects over 10 days, if it occurs again, it's now going to turn purple to say, hey, this isn't updated. We continue to see this. And it's just a really nice view for your team to be able to not only scroll across every one-off defect in your fleet, but now be able to dial into these recurring issues that are causing problems and hindering fleet reliability. So let's continue a little bit more. So now that we've seen this cluster, and we say this is definitely an issue. I want to talk a little bit about, what Chris was talking about is the technology behind it. So one of the major differentiators of Veryon's tool is that we are not clustering via ATA code that is entered. We are clustering via description. So I want to throw it out there for all our folks in the chat. Raise your hand or tell us how often does this ever happen that a pilot or a maintenance technician might miscode an ATA? Does that ever happen? Maybe they get two digits right, but not four. So maybe somehow we've miscoded that ATA for a defect. Okay, well, now let's talk about our quality team and our reliability team and our fleet managers and our airworthiness directors. Well, if you're trying to wrap your head around this and you say, okay, I'm going to export all my data, show me all of the errors in chapter 52. Well, you might miss some because they are not going to be correlated to the original issue because they weren't clustered correctly based on ATA. So the Veryon defect analysis tool is clustering via description. And you can see that NLP model working in the background because it's going to know based off your linguistics, RH is right hand, right engine, right hand, RT. If it's smoke in the cabin and you put SMK, it's going to catch that and it's going to know that that's a related incident to a right hand engine or smoke. So now that you can see the type of report, the tail that it's associated with, when it was reported, the ATA that was put in there, this is the description, and these are the corrective actions that my team has taken. Now, this is where it gets pretty powerful. So now you can start to say, you know what, this is an issue that I don't want to see continue to happen. We checked, everything was fine, we continued to move on. It could be all kinds of defects that you're looking at, but this recurring issue we have a problem with. Well, now you can quickly comment with your team. Hey, John, let's monitor and don't MEL the next one. Let's take a corrective action. You can share that chronic among your entire team. And so you can share across the entire team to say, hey, pay attention to this one. Or if you find the final fix, you can send that out as well for quick cross-based collaboration. And the goal there, guys, is that if you're able, right, let's just say you MEL the first one, you kick the can, you reset it, it occurs again, it pops up in your recurring list. Now you've tried a corrective action, that didn't work, it pops up again. Well, the third time you make a fix, it goes away. The system's going to know it doesn't pop up into that cluster. That means that was a final fix. So now the final fix at your base becomes the first fix at the next base. And now we're able to start reducing recurring defects, mitigating AOG risk, and increasing fleet reliability. So we are very excited about this product that we're releasing to business aviation. So now this tool is very exciting, ready to go. As we mentioned, doesn't need, we'll run off of any M&E system we'll pull the data from. We can set it at a frequency that works for you. Maybe that's once a week. Maybe that's once a day. Large operators doing it every 15 minutes. We'll work to set those frequencies with you. And it can be up and running in 4 to 6 weeks. Pretty amazing. I challenge you to find a software provider that says they'll have something implemented and running, driving tangible ROI within 4 to 6 weeks. And the feedback is that they're seeing that ROI within 30 days of use. Pretty incredible. Now, the future of this tool and some of what Chris talked about was our initial symptoms tab. So now, if you're inside one of your clusters, you see the corrective actions that you're taking, you can toggle over to your initial symptoms tab, click in, and now you can start to see the known possible solutions and what's been tried across your fleet. So you can say, okay, these known possible solutions, there's 10 of them. We can R&R the lube unit, remove and replace the gearbox deoiler. There's clean oil drain mast. Oh, here's the one we just tried, Tighten oil coupling module B unit. Well, this gets more interesting, team, is that now you're able to not only benchmark against what fixes have you tried, but against that Veryon global de-identified fleet. So now we can see what is the fix effectiveness rate amongst my fleet when I've tried these corrective actions, and what is it against the global fleet to see how you're stacking up. So this is a very good example. Let's just look at this. Tighten oil coupling module B unit is the last corrective action we tried for this. Well, look at that fix rate. It's got a 7% fix rate. Now up here though, the R&R of the lube unit I've tried this 3 times across my fleet and it's got a 20% fix rate. Well, the global fleet has done it 5 times recently, and there's a 28% fix effectiveness rate for that R&R of the lube unit. So now guys, instead of throwing parts at something, instead of doing this, instead of trying something or kicking the can, you're able to take actionable insights, make a decision, and then share that out across your team to get your fleet reliability back where they belong in the air. So that we're very excited about this, and that's going to be how the AI is going to be routing that based on those corrective actions taken, where you're also referencing, those technicians are referencing the MMs. So now from here, as a leader, you'd be able to click right into your dashboards and see. Now you can start to monitor how many tails do we have? How many total number of defects? What is the average chronic size? What is the average duration in days? What's the delay count in minutes? Almost 3,000 minutes of delays. You can monitor via your fleet down by tail number. You can look at ATA chapter, and I'm scrolling through quickly, guys, so don't worry, we can get you your own personal demo. You can see what ATAs are giving you the most headaches. You can scroll over to your fix effectiveness. And this is really the future of this product that we continue to develop. Now you're able to see what are your fix rates across your fleet. What are the costs that are occurring? For my, what are my total costs? What is my first time fix rate? What are those fix rates? How can I benchmark against the global fleet of this type of aircraft? How am I looking across ATA chapter, right? So we've got bases along the bottom and ATA chapters along the left. So now you can see, okay, at SLC for ATA chapter 51, I've got a 100% fix rate. Oh, at LAX for chapter 28, I've got a 0% fix rate. Guys, we got to get in there and fix that. I've got a 79% fix rate for chapter 32 at JFK. You can scroll in and see which bases are giving you the most defects. Pretty incredible and powerful technology that is designed to enhance reliability, reduce risk, and help you guys as you all work to satisfy. I know the FAA just came out with that CAS requirement for 135s last year. It's mandated. What a great way to be able to see all your defects in one single pane of glass and share them out to your teams. So now, guys, just a quick overview, really fast. That was a very quick overview of how you can quickly view every discrepancy and corrective action in one place, spot recurring issues faster, and turn your data into reliability insights so that you can enhance fleet performance. So now with that, we want to bring in our special guest. He's already joined us. We've got Wyatt Robertson to join the discussion. Folks, I just want to get open for him really fast. With over 29 years, Wyatt, thank you for your service. 29 years in aviation. Wyatt is a quality manager. He's an FAA licensed A&P professional. He leverages his expertise in maintenance, quality management, and process improvement to ensure the highest standards in safety and performance at his operation. He has led multiple aviation programs, including helping to start 3 Part 135 ops. Okay. Now, outside of work, he's also an avid hunter and loves to travel. So if he's not in the woods or setting up a 135, he's on his way to his next exciting destination. Wyatt, thank you so much for joining us, sir.
Yeah, thanks for having me. Love the energy, Kyle. Thanks.
Thank you, sir.
Hey, welcome, Wyatt. So I just wanted to first let the audience know a little bit about your specific role at Wing Aviation. If you could tell us a little bit about Wing Aviation, what you do there, what your maintenance operation looks like day to day.
So we're a Part 135 operator, 10 or more. So we have about 30 aircraft. So, day to day, it's pretty hectic. With 30 aircraft, you got to be pretty aligned. So, my major job here and the whole team's job here is, to ensure, we're operating safe aircraft and doing it in the most efficient manner possible, so we try to leverage, some tools to help us do that. So that's pretty much the day to day here.
Great, great. Thank you. So if we get a little bit more specific then, so every operation kind of tracks repeat defects a little bit differently. How does your team currently identify and manage recurring defects across those 30 aircraft?
Well, it's very basic, right? So I'm pretty much every time I hear something, I get with the team and we're kind of just sharing off memory and looking at records and historical data. I mean, it's very basic and really not the most ideal way to do it, with when you're, have this, many flight hours and, operating this many aircraft.
So how long would you say it normally takes you on a daily basis, out of
Y-
curiosity?
So if it's, something we've been messing with day to day, I mean, it take, 30 minutes or so, but sometimes if it's, not one off type incident, it might take me, 45 minutes an hour to figure out the whole history of something,
Yeah.
Really?
and share that and try to figure out to, get it to the mechanic in a timely manner to, help him, analyze it and understand what's already been done before he wastes a lot of time.
Absolutely. I love that you said that before he wastes a lot of time, right? And this is the whole reason when you look at outdated operations, analog functions, items, and that's where I kind of wanted to, just kind of ask you as you look forward, because you're very forward thinking. When I think about folks, no longer is it that the director of maintenance or the quality inspector or everybody, it's really not just, a wrench and a rag anymore, right? Like you are focusing on the analytics of everything that's going on across your fleet. So I kind of, you've kind of alluded to some of them now, but what are some of those pain points that made predictive maintenance a priority for Wing?
You, so the biggest pain points, are, our manual workflows are inefficient, error prone, very time consuming, and it leads to lack of visibility and, proactive insight into our maintenance status. I mean,
No,
that's bottom
absolutely.
line.
Absolutely, absolutely. And now, so as you see tools like this, right? And we do value as a customer, we appreciate that. But as you see tools like this start to come out, and other forward-thinking companies, developing software solutions that are going to help, what kind of stands out to you about this solution that would kind of make you say, you know what, this definitely would be a fit for my operation, other than eliminating some of these manual operations, right?
So the biggest thing that stands out is, you can quickly see the data in a useful format, right? So, once we, get understand a little better, get to using it a little more, we'll be able to do that, even quicker. However, but it's still pretty, straightforward in my opinion, but I've been dealing with, a lot of different tech type stuff over the years, so I'm pretty familiar with a lot of it. But however, you got to have that data, and some of the data that's contained in there, I've used just and created, Excel charts for our cast meetings, and some of that stuff takes, weeks, not days or minutes, or that this data is already doing and compiling for you, which is what you need. I mean, if it takes me 3 weeks to, analyze some data, by the time I'm finished looking at it, it's already changed, so you need that
Exactly.
real-time data.
No,
Yeah.
exactly.
So when we're looking at a tool like this that kind of uh, creates analytics based on data that you're throwing into it, like there's an element of trust that we need to build. How, like in this occasion or over the years as you've been opening up 135 operations, how have you and your team built confidence in the insights? Any predictions that the system might produce?
So you gotta, so to Well, it's a great question. So you got to start, the first step is to completely understand it and incrementally, bake it into your process. You got to start with piloting a single subsystem, which leads to, so that helps you, benchmark and validate the data. So you can, eventually integrate it into your workflows. And once you do that, you got to totally understand it so you can use it to your best way and work whatever works best for your operation into that workflow. So you're not putting anything unnecessary in there as well, or making it more difficult. I like to keep things as simple as possible. So when you have a tool, you don't want to, you just want to use what's valuable for you, uh, in your workflows. You don't want to, create a more complex, workflow or process, et cetera.
Kind of
100.
working smarter, not harder, right?
Yeah.
Exactly.
Yeah.
100%.
So now that you're adopting defect analysis, what do you expect to see in areas like AOG reduction, faster troubleshooting, just overall efficiency that makes this process a lot smoother for you?
So it's the biggest is, the real-time shared visibility, prioritizing our scheduling, more accurate decision making, faster, more accurate decision making. That's how I see it initially.
Okay, that's really good information and good insights then.
What
I, yeah, go ahead, Kyle. Did you have a question?
I was just going to ask one as well. It's just, so as you're kind of moving through this, what advice would you give to other operators who are considering moving from manual processes or manual whether it's defect tracking or predictive maintenance? What advice would you give? Because sometimes what we see, Wyatt, is a lot of folks are just on the fence. I've been doing it this way for 30 years. No, 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 I've got my Excel workbook exactly how I like it. What advice would you give them? Because, in seeing you, as you mentioned, you are no stranger to technology. You have been always forward thinking. You are working on develop, basically, looking at the tech stack at your current operation and seeing how you can bake in tools that are going to make your lives easier and make things faster. Kind of would love to kind of hear what advice you might give to other operators who are kind of on the fence of making the move to new tools.
I would say get in early. The earlier you get in, the better you can help shape it. The better you can, use that tool without complicating the process. Or, later on, if you get in super late, then it just seems like a tool that's, more of a novelty than the actual. You can't find the value in it, but if you get in early, man, you can there's value in it, and you can use that value to help.
So along those
Absolutely.
along those lines, then, um, good looking at the future and like how these teams are supposed to be working in the aviation space, and like Kyle mentioned earlier, it's no longer a rag and a wrench anymore. So then, how do you see analytics and predictive tools kind of shaping what a maintenance operation is going to become?
So I we'll be able to, harness the whole industry's data to help quickly troubleshoot and fix things, and help eliminate, be more predictive than reactive. You know what I mean? And actually you'll be able to find failures before they come almost. I mean, it's going to take some time, but once that data goes in there and the more, those tools are used, I think, we can really change this, the whole shape of our whole maintenance tracking as well. Because I mean, if you're doing, the same inspections year over year, we can be way ahead of the OEMs and say, well, I've done this 100 times. I've never found anything. So why are y'all telling me to do this every 24 months when I should be doing it every 48 months, and save some downtime, save some wrenching on an aircraft, unnecessary wrenching on an aircraft. I'm all about, ensuring the safety, but sometimes, you don't want to tear something down, 20 times and you never find anything. What's the point of tearing it down? You're going to create an issue, right? So the whole idea is a safer operation. So the less you have to tear it down to inspect it, the better off you are.
That's a great point, Wyatt. I love that you said that because we've seen, right? I think with the information and great operators, I mean, that's what it takes. The OEMs put out great products, the operators start running them. You see the issues, you see what the maintenance manual recommendation is. But if you're able to come back and say, hey guys, shouldn't we author this out to 48 months? I mean, look at all of the data. And I think that really pulls us back to just that's where it's all going, right? Enhanced data capture, advancing technologies that are going to keep moving things forward so that you can, one, run a safe operation, two, have more uptime and fleet availability, and really just continue to improve the overall availability of the fleet. I really appreciate that. That's a thank you so much. Anything else to add there, sir?
I mean, I don't unless somebody has any
Okay.
questions.
Perfect. Well, wonderful. So Wyatt, we really appreciate it. And I know Chris and I are just kind of, hammering you with these questions. So you did a great job. We want to thank you so much for being here and stick around with us now. Here, what we're going to do is we're going to turn it to our audience. So we've got a few minutes left, right? A little over 10 minutes left to kind of use this remaining time to answer some of the questions we've seen coming in. So our team is kind of sending us these questions, and we will jump in here and start looking to see if we can't ask them. Um, so one of the questions we got was, how does the system determine the first time fix rate?
I can take that one,
Well,
Kyle.
thank you, Chris. Perfect.
Yeah, yeah. So basically, when we're looking at what a first time fix might look like, I mean, logistically speaking, it is difficult to determine if a fix is a first time fix because if the defect happens again, then it wasn't a first time fix. So it's literally just looking at whatever either the guidance or the operator wants to use as their threshold for what would classify the the time frame that a defect would fall into a cluster. For instance, we can look at cycles, we can look at hours, we can look at days. And so like if we don't have another similar defect within 30 days or within 40 cycles, then that would become a first time fix because it is no longer reoccurring for that one. So it's not that we can get immediate information about a first time fix, but it will come naturally as the repeats don't come for that aircraft anymore.
Excellent. Thank you, Chris. Absolutely, guys. So that's really what it is. If you try something and then that doesn't pop up based on those auto tags that you've chosen 2 and 10, 6 and 33, whatever it is, then it would fall out and it says, okay, we have identified a first time fix for this. And then you can continue to monitor it, right? And Chris, they can set alerts. To see if this occurs again. They can watch it to see if it pops back up in a cluster. But all of that information is right inside the system for you, just at an easy with a very good user interface. Really appreciate that question. If there's any other questions that we've got, I would love to hear some of them that are coming in. I think I've got one here. Stand by.
There's another one here. Could you provide a real life example of how an AOG could be predicted and prevented? Uh, so yeah, I mean, we could look at a specific pattern. So for instance, let's say we have high oil temperature readings or leaks of some sort, and we see that surfacing on the same engine type. Um, and so the event might look isolated for that particular aircraft, but we could look at the different pattern across the whole fleet to basically find that we have some kind of issue with rising oil leaks or whatever it might be. And then we can plan and inspect around the next inspection. We might want to inspect that particular component or replace it completely so that we kind of prevent an AOG to begin with completely.
Absolutely. And Chris, thank you so much for that. And guys, though, I really think this is such a great one for Wyatt. Wyatt, I mean, you're out there every single day in it. Can you tell us a little bit more, give us some insight onto this one?
Absolutely. So, if if this system works like it should work, and you can call Kyle if it doesn't, but if it does work like it's supposed to work, say something, as simple as, tire wear. So if you have an aircraft that, you're monitoring, it's at like 4/32 of an inch, uh, it, this working properly, you can predict that you're not going to have an AOG in Montana because you need to change a tire. You'll know that, unless it's outside the scope, they have a hard landing or something, but normal wear and tear, that you got, 15 more landings easy on this tire. And, from your schedule, will be back in your shop in 6 days, and then you can plan it. And that's kind of one way I see how that can work. And I mean, that's a simple aspect. I mean, some AOGs like a pressurization issue, I don't know, but things like wear and tear that you can measure or monitor full time, I think you could help. It'll help on AOG issues, but it's when you have that system up and running, you got it in your workflow, and you're using it every day by all means.
Absolutely. And just being able to see, right? So now instead of having to dig into an Excel file or start with a single chapter, if you can, just over your coffee, you can scroll through every defect that's occurring. You've got your alerts working for which ones have been recurring or what you want to keep an eye out for. And then you're able to kind of get in there and not only be proactive. I think that's where we start to shift from being, hey, I'm being very proactive with these tools, which starts to lead to those predictions like you're talking about. Like, hold on a second, this I'm in that threshold. Maybe I want to elect to make a change now. So great answer. We had another one come in that says, at the time I transitioned my fleet onto Veryon, would I go back into my historical tech records and pull the old defect data into Veryon? So when Chris, I'll let you elaborate, but we can pull that information from whatever system you're on now. And at the time you transition over, it'll just continue to rewrite, right? So you'd have all of it going all the way back to the start.
Yeah, and just remember, historical data is valuable, right? Because like, not only can we determine if the structure for clustering or even for parts that air is using to learn patterns a little bit faster is working correctly for the future, but it just gives us a sense of where your operation has been. And we don't need every single piece of data that you offer. Like Varion can help clean and structure the data so we feed the analytics that it necessarily needs. The goal is basically to be balanced. So enough history to spot trends, but not so much that onboarding slows you down at the end of the day.
Excellent. No, thank you so much, Chris. Now, we've got another one here too as well. I kind of, and this I think is really important for the audience as we all start to work towards, getting confidence in some of these new tools and technologies coming out, right? So how do you balance trusting AI-driven insights with the hands-on experience of your maintenance team? And I would say that you're really, it's a marriage of the two, right? You're using the new advancing technologies as a guide. They're not a replacement for experience. But now, a lot of these, data tools, it's kind of an opportunity. We see workforce shortages. We see, we need more technicians. You've got a lot of young, greenhorns coming into the shop. How do we get that tribal knowledge to them faster, right? And instead of having to wait or, I'm sitting here in the FIM and I'm troubleshooting now, it's like, okay, I've got some quick insights of what my other, maybe even more seasoned technicians or maybe not, what have they done? What were the fixed rates of those actions that they took? So I really think that it's kind of combining data insights with technician judgment, so that you can have that drive quick action, so that you can get those birds back up in the air. But I think that is something that we're seeing. A big thing we like to say here at Varion is there's always a human at the wheel. Right. So, we're injecting Gen AI across all of our platforms so you can start talking to your fleet and asking it, does it, but now you're still in charge. You're going to say, you know what? I really like what it said, but I also know there's another inspection in December that kind of lines up with this. I'm going to add this one to that work order because I can knock it out while I'm in there. And that's where that kind of, tribal knowledge of our great seasoned technicians and the technology can help drive, kind of seamless execution in your workflows. So great question. Is there any other, guys, keep lighting up that chat. We want to see them. I'm in the webinar chat section, kind of watching for these questions. Jeff, thank you for asking that one. We've got just a couple of minutes left, so please, we'll kind of stand by for a couple more. I'm going to look through our list here as well and see if we can dig up another one. What do we got here?
Great question.
Are you able to see data about parts vendors and the reliability of part repairs or overhauls? So to answer that question, yes, that is in the pipeline of something work. So we have another tool. Like we said, we have a big ecosystem of tools within Varion here that's called reliability that does have parts information. And so we're building a pipeline to get more of that parts information into defect analysis, because ultimately, planes don't break. The components on a plane break is what the problem is. So we need more visibility into what is the life cycle, the threshold of how long parts should be working. And so we want some of that visibility to come into defect analysis. So that is a piece that is going to be coming into Q1 of next year.
So really excellent. I like that but I just want you guys to know, I feel like Eric's almost taking it a step further. Like, Eric, that would be a great tool to see, right? And I think for some of those suppliers and vendors, they might want to adopt certain tools that show, hey, every time I put out a brake assembly, it's got a 98% reliability rate. And it's not pulled off as a rogue part or something. So I think that is absolutely the future. As Chris mentioned, there are tools right now where you can kind of set thresholds around, hey, we know the says 2,500 hours is when it fails, but we all know it fails at 2,250. So maybe I want to make sure if the aircraft's down at the base, I can pull that piece now and get it moving before it, causes something down the river. Excellent question. So one of these last ones, let's see here. What advice would you, let's see, we did talk about that a little bit. What advice would you give teams that are hesitant to trust these predictive insights? I think we talked about that. It's really a marriage of, you're at the wheel, reviewing your information. You've got really great tools right now, though, that exist, for you guys. So, by utilizing these tools and as Wyatt mentioned, kind of just, slowly baking them into your processes, right? And seeing where they work, where they don't, where they need to be improved. But then also measuring some of those soft costs that you're saving. Holy cow, this just saved our team, hours of work. Instead of having a whole section of folks that have to dedicate all these hours to this, maybe we would be able to task them onto other tasks because they're able to use these tools. So now, guys, we've got one more poll that's going to be launched, I believe, and it's going to kind of ask our attendees, what is your next step? We'd love for you to click in there and answer. We want to thank everybody for joining today. We greatly appreciate all of your time. I feel like we're right up there. So please get your answers into that poll. Wyatt, thank you so much for joining us today, sir. This was wonderful.
Thank you, Wyatt.
Chris, really appreciate you being here and taking time out of your day, sir, as one of our product leaders. Now, again, guys, if any of you would like more information, simply raise your hand, click on that poll, or reach out to us after the show. We want to thank everyone for joining today for this session on Predict and Prevent with Veryon. See you next time.